right, Unit 4, practice free response question 1 is a calculator question. So hopefully you guys have your calculator or you're using one that Texas Instruments provided. But anyway, on this one, baseball fans enter a stadium at a rate modeled by the function E, given that E of t is that function, and that is for t is between 0 and 6. And then they leave the stadium at a function modeled by L. Both E and L are measured in thousands of people per hour, and T is measured in hours since noon. T equals 0 would be noon. And the total number of people in attendance at the stadium are given by A. So the first question asks us first to find E prime of 2. So because this is a calculator question, we can do that in the calculator. I'm not sure on our exam this year if they'll ask you to do something like this without showing any work. So there's a good chance on the test that you would need to show the process of finding E prime of t and then plugging in 2. And then, of course, you could use your calculator to find the value whenever you plug in 2. But anyway, when you do it, you should get this decimal. Don't forget to make sure you are accurate to 3 decimal places. All right, the second part, using correct units, interpret the meaning of E prime of 2 in the context of the problem. So E, the units of E are thousands of people per hour. So this is E is people per hour. Whenever we find the derivative of a function, we're dividing by the independent variable. And our independent variable is time. So we start off with people per hour and we divide by hours. So it's going to be people per hour per hour. And when we write this out, make sure you use the words of the problem. So fans enter the stadium at that rate. So I'm going to use the same words maybe in a different order, but we're going to use them. So the rate at which fans, or baseball fans, doesn't matter, are entering the stadium All right, now it's important that we recognize what the 2 is. And so that is at t equals 2 hours is, all right, and then because it's negative, I'm going to say decreasing at a rate. Now be careful on this one. This is measured in thousands of people, so we wouldn't say 0.88 for people. We would multiply that by 1,000, so it's technically 884 fans per hour. Per hour. All right, so we take that original unit, people per hour, fans per hour, and we divide it by another hour. So the rate is changing by people per hour per hour. Okay, now it's very careful. You need to be very careful about how you word this. The rate is changing, not the number of fans are changing, the rate that they're entering. So again, it's important. Go back and use their words. Okay, so this one talks about a different part of this problem, and it's A. So it tells us in the problem that the total number of people in attendance at the stadium is at time t is given by a prime. I'm sorry, it's given by a. So we want to find when the derivative of a prime of t, is equal to 0. So a of t is the total number of people in attendance. So a prime of t is the rate, the total number of people changes at time t. All right, and so what we would do to find a prime of t is take how quickly, or the rate at which they're entering the stadium, and then subtract the rate at which they're leaving the stadium. All right, so if you're using a calculator, I would go ahead probably and put, or if you hadn't already, put E of t in for y1 and L of t in for y2 if you want to. We could go ahead and just write it all out and put it in the calculator at one time. So there's lots of ways you can show this to the people reading your test. Either way, you're going to need to put that in the calculator. And then we want to use the calculator to find when this is 0. And it's important that we're using the interval they give us in the problem. We're finding between 0 and 6, and we are including 6. So when you look at the graph, you don't really see the 0 at 6. So it's also important that you either plug 6 in and see what you get, or you look at the table. But using the calculator, a prime of t is 0 at t equals 1.42 and t equals 6. Okay. All right, so on the next one, C, at time 4, there are 22,063 people in the stadium. Write an equation for the local linear approximation of A at t equals 4, and then we're going to use it to approximate the number of people in the stadium at time t equals 4.25. All right, so they're asking us, when you're asked to find an equation for the local linearization model, that's asking you to find the tangent line. We're going to do tangent line approximation. So those are two different ways. The local linear approximation and tangent line approximation mean the exact same thing. And so to do a tangent line, we need two things. We need the point of tangent C, and we need the slope of the tangent. So the point of tangent C is going to be A of 4. And it tells us that, see, A, if you guys remember, is the total number of people in attendance. And then it tells us at time 4, there are 22,063 people in attendance. Ooh, no, I did that, and then I did it right, and then changed it. We do want to write that in thousands. right, and then the slope is going to come from the derivative. All right, and we already have probably the derivative in the calculator. Under you may have it in y3, you may have it in y1, but we can use our calculator to find it. Remember, a prime of t we wrote right here, and if we use our calculator to find that, we would get negative 3.541. Ooh, we're just going to plug in the value. We just plug in for t. We don't actually have to do like the derivative buttons, because this is the derivative. We don't have to do like the calc or the alpha window to figure it out. We can just put 4 in for these t's, and that gives you the value. So be careful with that. Pay attention. All right, and then once we have our point and our slope, we can put these into point slope. All right, and they are going to want to see the equation. So typically, I don't really know this one that they didn't label the points or assign points, but typically you do get a point for writing that equation, and then you get a point when you plug in the value for t that you're approximating. And then move the 22.063 to the other side. All right. So what this means is we're going to predict that at time 4.25, there are 21,178 people. Oh, and also, if I'm looking at my notes, I'm not actually typing it in the calculator right now. It looks like you would also get perfect points for 21,177, because that would be the truncated answer, and then the rounded answer. They're both perfect. All right, and then this next one is a related rates question. And we spent a lot of time on related rates, and you guys can't forget all that stuff that we did. It's been a long time since we have referred back to it. But for D, the square formed by connecting the bases on a baseball field is called a baseball diamond. The distance between each set of consecutive bases is 90 feet. The player is running towards third base at a rate of 20 feet per second. When the player is 20 feet away from third base, at what rate is the player's distance from home changing? All right, so you have somebody running this direction. All right, so we'll say that there they are. All right, this 90 feet right here is not changing, so we would label that 90 feet. All right, I'm going to call this B. That is changing because the player's running from second base to third base. And then I'm going to call this C. And that is also changing because this player's moving in this direction, which makes that distance change also. So there's my diagram. All right, and so I'm going to go back to the old way we used to do this. I'm going to write down what we're given. So what we're given is that the player runs toward third base at a rate of 20 feet per second. All right, so that means that this distance B is changing at that rate. So we're going to call that distance dB over dt. Now you have to think about, is that distance getting larger or smaller? So the distance between the player and third base, that distance is getting smaller. So it's technically negative 20 feet per second. All right, then we're going to write down what we want to find. So we want to find at what rate the player's distance from home is changing. That is going to be, the distance from home is C, so we want to find dC over dt. Oh, I left out the word find. When, and then that's going to be the magic moment. And the magic moment is when the player is 20 feet away from third base, and that is B. The distance from third base is B. So when B is 20 feet. Okay. So the relationship between these sides of this triangle is the Pythagorean theorem. So our formula we'll use is going to be 90 squared plus b squared equals c squared. Right? And then we are going to find the derivative of that. So the derivative of 90 squared is 0. And then this is going to be 2b dv dt equals 2c dc dt. All right, and then I'm just going to mark the 2's out because we can just divide by the 2's. Okay, and now we're ready for the magic moment. The magic moment is when b is equal to 20. Now, the thing we're looking for is dc dt. So this is what we want. Oops. This is what we want right here. So we know b, and we know dv dt. We do need to know c. So what we would do to find c is plug b into our equation right here, and that can tell us c at the magic moment. So c is going to be the square root of 90 squared plus 20 squared. Which is going to be 8,500. The square root of 8,500. Okay, so I'm going to plug everything in and then solve it for dc over dt. All right, so that's going to give you negative 400 divided by the square root of 8,500 is dc over dt. Okay, and then we would want to answer the question. So when the player is 20 feet away from third base, at what rate is the player's distance from home changing? So we would write out a sentence. When the player is 20 feet away from third base, the distance the player is from home is, and we would want to go ahead and well, technically, I think they would take that as the answer, but you will have a calculator that you can use, and that's going to give you this. So because that is a negative rate, we're going to say the distance is decreasing at a rate of 4.338 feet per second. Okay. Now, I fully predict that you are going to have a related rates question on your test. A lot of times in the past, like the recent past, they put them on the multiple choice. But with you not having any multiple choice, there's